Hello and welcome to our penultimate video in this unit. We have basically done everything there is to do with the unit circle. We've looked at it, we've been on it, we've moved around on it, we found terminal points, we've used those terminal points for coordinates, which we then use to define sine, cosine, tangent. We then graphed sine, cosine, tangent, we then transformed those, and then we tried to undo them. We created inverse trigonometric functions. We have done a lot on the unit circle. And so the time has come to start to move away from it. You see, it's a very profoundly mathematical thing, and actually a very profound scientific thing, to come up with results for some situation and then ask, where else does this apply? Or how else can I use these things that we found? Because we have put a lot of effort into defining trigonometry on the unit circle. Well, is it going to be the case that if we move off the unit circle, even if we move onto a slightly different circle, is all of trigonometry as we know it just going to cease to be? Hopefully not. And as we'll see, absolutely not. But just to get us going here, suppose that my universe consisted not of the unit circle, not of the circle of radius 1, but rather of a circle of radius 2. Can I redo trigonometry for that? Or can I generalize what I found on the unit circle to this new circle? And the answer is going to be yes, yes I can. So, starting off though, suppose I moved on this new circle, circle radius 2, by pi over 2. Now, whereas before on the unit circle, that would put me straight vertical on the point 0, 1, that's not where I'm going to end up here. Reason being, on a circle of radius 2, that's of circumference 2 pi r, that's circumference 4 pi. So the terminal point, having gone pi over 2, is just 1/8 of the full revolution. So we're going to end up not up here, but rather here, 1/8 of all the way around. Now here's the thing. This point corresponds very nicely to the point we would have found on the unit circle if we had moved half the amount we had moved on this new circle. Right? Moreover, we've got similar triangles on our hands, right? If we recognize this to be one triangle and this to be another triangle, oh boy, I've really drawn over this, we have similar triangles. Moreover, we have an established ratio between them, right? This hypotenuse here is of 1 because we're on a circle of radius 1, whereas over here we're of radius 2. So all of these lengths are doubled. So cosine pi over 4 becomes double that for x, for our new point on our new circle. So that's 2 cosine pi over 4. Here it's 2 sine pi over 4 for the y-coordinate. So we get, via this multiplier of the radius, the multiplier of the terminal points. We have established ratios that we can exploit. Specifically, if I'm on a circle of some arbitrary radius r, if I move around that, and I'm similar to some point on the unit circle that was produced by having moved some amount on it, the terminal point, the terminal coordinates for our new point on our new circle is going to be r cosine, r sine. But now, this idea of moving and relative movements doesn't really work. That's what's going to have to change now. What's going to have to change is instead of viewing everything as movement by some amount on the unit circle, we're going to look at it all as having been rotated and corresponding to those terminal points. And so we're going to start using theta instead of t, right? T was for movement. Theta is now going to be for rotation. The way we have rotation and angle measure defined, right? The way we define angles in this course is to be the amount we rotate equal to the amount we would have produced by traveling on the unit circle. So everything ties in very nicely. It's just now we have to generalize rotation from movement onto the unit circle to rotation on the unit circle to rotation everywhere. Let me show you what I mean. And I'll go back to what I just have there. Here is the unit circle in red. But suppose I am now looking at being at circle radius 2. or really circle radius anything, and I'm wanting to rotate or move on that new circle, or just rotate in general, the way I find that is by taking my initial side, right, taking that side and rotating it by whatever angle I'm choosing to use. Notice that if I choose t to be, say, pi, then I've gone all the way, well, not all the way, right, but half of a full revolution, which is what you would expect, right? Because moving pi on the unit circle would put you at -1, 0. If I moved pi over 4, if I rotated pi over 4, rather, then my terminal side is going to correspond with where I would have ended up on the unit circle having traveled pi over 4. Or, in general, as I just rotate around, my terminal side, where I end up, corresponds to the terminal point I would have had having moved that same amount on the unit circle, or having rotated that same amount on the unit circle. And these blue coordinates here, all of those are r cosine theta, r sine theta. So that's how we generalize that. Right? The initial point, 1, 0 becomes the initial side, the positive x-axis. The distance that we move on the unit circle now becomes the angle of rotation around the circle, any radius. The terminal point, which was cosine t sine t, is now r cosine theta, r sine theta for our terminal side. And also, coterminal points, right, if we had ended up at the same point having moved different distances, those were coterminal points. Well, now we have so-called coterminal angles, that you can have different angles of rotation that produce the same terminal side. So we have coterminal angles now as well. And that is that. That's how we're defining rotations and angle measure now. It is going to be exactly the same as before, except now generalized from the unit circle to anywhere. Let's see. I got a little more time here. I want to go ahead and get this out of the way right now, so we'll have it for the next class, which is we got this degree measure nonsense here, and I want us to finally address that once and for all. We've got two modes on our calculator, radian mode, degree mode. We've been working extensively in this class so far with radian mode, but degree mode is a very scientific, very human invention, very necessary invention, so let's get into that. The short of it is, one revolution, one full rotation, is 2 pi radians by definition. Also, by human definition, by our own convention, one full revolution, one full rotation is 360 degrees. So, 2 pi radians equals 360 degrees. If we can turn that into a conversion factor, which we can just by dividing both sides by each respective side, we get that if we had some radian measure, we multiply by this ratio, 360 over 2 pi, or 180 over pi, and that's our degree measure. Conversely, we would take our degree measure and again multiply by now 2 pi over 360, which is now pi over 180, to get the radian measure. So which is better to work with? Which is more intuitive? Well, that depends on the situation, right? If we're working in fractions of pi, then radian measure is ideal. If we're working elsewhere, then we might not want to do that. For instance, suppose I tried to work in 2 radians, not 2 pi radians, but just 2 radians. Where is that? That's a hard question to answer, but if I converted it into degrees, I get about 114.6 degrees. Now that is something I'm able to visualize, right? I can do fractions of pi all day with radians, but without pi in the mix, I don't rightly immediately know what I'm doing. So degree measure might be better for that. So it's a matter of situation. It's a situational issue, which to use. And actually, as we get into the application problems of this, I will show you very specifically that sometimes you have to use radians, and sometimes you don't. It really just depends on what you're trying to do. So hopefully in this course, hopefully in the start of this course, having done it through radians exclusively, you have a bit more comfort and familiarity with radian measure. And if not, well, hopefully you can improve on that. At any rate, we have now reached a good stopping point. We have now defined angle measure, we've defined rotation, we have all that couched through a very similar process to what we would have had we moved on the unit circle, and I think that's a good place to stop. So let me know what you're struggling with, let me know what you're wondering, and we'll get that addressed at the start of our next class, and I'll see you then.